So this is our third and final video dealing with percents increase and decrease. The objective for this video is we want to find two things. We want to find the percent change or the original amount in percent increase and decrease problems, So we're going to find the percent change in percent increase and decrease problems, and we're going to find the original amount in percent increase and decrease problems. Okay, this is a little more complicated, and so let's review briefly what we already know. Okay, number one, we know that percent change is the amount of the change, either an increase or a decrease, expressed as a percent of the original or a percent of the beginning amount. Okay, so again, percent change, the amount of change expressed as a percent of the original amount. And we know the amount of change equals the percent of change times the original amount. We're going to pull in these two ideas in this video. Okay, of the two objectives, I would suggest that finding the percent change is the easier of the two. So let's take a look at how we're going to do that. We're going to take this equation, so we're going to find the percent of increase or decrease, the percent of change. We're going to start off with this equation right here. We know the amount of change equals the percent of change times the original amount. Okay? So I rewrote that equation, and I want to find the percent of change. So since it's being multiplied by the original amount, I'm going to solve for it by dividing both sides by the original amount. Okay, and then we know that this times this divided by this, that this is a common factor, so that's a 1. So we're left with percent of change, and I'm going to write it on the left side. Is equal to the amount of the change, I'm abbreviating the word amount with the AMT, the amount of the change divided by the original amount. So there you have it. The percent of change is the amount of the change divided by the original amount. Okay? And we're going to do the same thing, but this one will be a little bit more complicated. We'll see that in our problems. We're going to do the same thing to find the original amount. We know, again, we'll come back up here to what we know. We know the amount of change is equal to the percent of change times the original amount. Okay, so I'm going to write that down again. The amount of change equals the percent of change times the original amount. This time, however, I want to solve this equation for the original amount. So I'm going to divide this side by the percent of change. So the right side will have the original amount all by itself. It'll be solved for. And in algebra, I always do the same thing to both sides. So I will then divide this side by the percent of change. And again, we know that this factor, this divided by this is 1. Whatever this number is times this number divided by this number, this is a common factor. Divided by itself is 1. So I'm left with on the right side, although I'm going to write it on the left, the original amount is equal to this division problem right here. It's equal to the amount of change, in this case divided by the percent of change. And I forgot one thing. Okay, I forgot one thing. Let's go up to here. I forgot something. Because we haven't included our percent of change, and in this equation, the percent of change is a decimal. What's going to come out of this is a decimal. So I need to take this, in order to get the percent, I need to multiply this result, this quotient, by 100 to get the percent. Again, because we do our math using a decimal up here, the decimal equivalency of the percent, in order to get the percent down here, I'll have to do times 100 to get the percent. Here, I'm going to use it as a decimal, and it'll give me the original amount. Okay, let's dive into this. This is where things might get a little confusing, but hang with me here on this one. Okay, example 1. The cost of a pound of nails increased from $2.36 to $2.53. What is the percent of increase? Okay, I'll go back to here. Okay, the percent of change is equal to the amount of the change divided by the original amount times 100. I'm going to write that down again so we have it in front of us. Percent of change. In this case, it's increase. It's an increase because it says we're looking for an increase. So our percent of change in this case is an increase, is equal to, I'm going to go back and remind myself here, the amount of the change divided by the original amount times 100. Okay, make sure you can see my paper. It's equal to the amount of change divided by the original amount, and multiply that quotient by 100. Okay, well, let's take a look. Okay, what is the amount of the change? Well, the change went from $2.53, it went from $2.36 to $2.53. The amount of that change is a subtraction problem. We're going to take 253 and we're going to subtract $2.36 because that's going to give us the amount of the change. Okay, divided by the original amount. Well, originally it started at $2.36. That was the beginning amount or the original amount, and it increased from there. So we're going to divide this by $2.36 and then multiply that by 100. Let's include this step in here. I'm going to take out my calculator. I'm simply going to do this subtraction problem with my calculator. So $2.53 minus $2.36. Okay, this is 17 cents. Okay, and I want to draw an arrow and make sure we're clear on this. This is the amount of the change. It changed by 17 cents. So it's important to understand that. That's the amount of the change. This is the original amount, the $2.36. We're going to divide those two and then multiply by 100. And I'll use my calculator for that. So 0.17, divided by 2.36 times 100. And the percent of change is 7.2%. And we know it's an increase. So it's a 7.2% increase. Is the percent of increase is 7.2%. Again, I'll be able to put increase in parentheses because the question did tell me it was an increase. So the percent of increase is 7.2% increase. Okay, let's do another one with a decrease. Okay, so in this case, we've got a chicken farmer who bought 2,575 baby chicks. Okay, of this number, 2,060 lived to maturity. The other ones passed away growing up. What percent loss was experienced by the chicken farmer? Okay, so we're looking for the percent of change, in this case, the percent that they decreased. So I'm going to write this down again, my formula, percent of change. And again, in this case, we're talking about a decrease because the number of chicks went down from a high number to a lower number. And it's going to be equal to the amount of the change divided by the original amount, or the beginning amount. Okay, let's take a look. Okay, the amount of change, well, that is a subtraction problem, and we went from high to low, and we always subtract, for this we always use the larger number to give us the positive change. So we're going to say we went from 2,575 and we went down to 2,060. That's going to give us the amount of the change, the difference between those two. And we always divide that by the original amount. Well, in this case, we started, our original amount, our beginning amount is 2,575. Whoops, I forgot times 100. 2,575 times 100 to give us the percent. Okay, I'm going to do the numerator separately so we see it. So I'm going to subtract 2,575 minus 2060. 2,575 minus 2060. Okay, so I have 515 chicks. And again, this is the amount of change. The number of chicks changed from 2,575 to 2,060, and that change was 515 chicks. The original amount is 2,575. Make it a percent by multiplying this quotient by 100. This is simply a calculator problem. 515 divided by 2,575 times 100. And this one becomes a 20% decrease or loss. 20% of the chicks were lost between when they arrived, when they were purchased, and when they reached maturity. So those are two examples to give you a sense of the first of the two objectives, or the first part of the objective, which is calculating the percent change. The percent change. Okay, the second part, I'm going to go back to my first sheet here. Now we're going to look at, so we dealt with this part to find the percent of increase or decrease. Now we're going to deal with this part. How do we find the original amount? Okay, so we're given the amount of the change, or we're given a part of it, and we're given the percent, and how do we go back to what was the original? A little more complicated here. It's going to involve a touch of algebra. Let's take a look. Okay, so here we are with example number 3. Okay, what was the original price of an item if the sale price is $240 after a 40% markdown? Okay, well, our formula tells us the original price is equal to the amount of change divided by the percent of change. Okay, I'm going to put in a letter in this case because it's going to play a role in this. The amount of change is a subtraction problem, and our numerator here has two parts, a higher number and a lower number. So we're going to have to do a little bit of substituting with some variables so that we can solve this. Remember, amount of change is something minus something. Okay, so let's take a look here. We're looking for the original price. So I'm going to put an X in for the original price. We don't know what it is. So I'm going to substitute an X in for the original price. Okay, what I know here is that this was marked down, so the original price was higher. Okay, so my amount of change in this case is going to be the original price. Well, I'll tell you what, let's leave this, maybe this make it a little bit easier. I'm going to leave this as original price. This is going to be the original price minus the sale price. That's the amount of change. Okay, the amount of change is the original price minus the sale price, because in this case, because it's a markdown, the original price is the larger number. And the percent of change, we know it's a 40% markdown. We're going to put this in as a decimal so that we can do math with it. 40% is 0.40. Okay, we know the sale price. The sale price is $240. Okay, so what I'm going to do is I'm going to put in, we don't know the original price. I'm going to put an X for the original price. So I'm going to say that we know the original price is X. X is equal to X minus $240 divided by 0.40, or 40% as a decimal. Okay, here's where the algebra comes in. Okay, first thing I know is that this is a fraction. If I make this a fraction, I will have formed a proportion. So X over 1 is equal to X minus 240 over 0.40. I simply rewrote this as a fraction, because when I have two fractions that are equivalent, I have formed a proportion, and I can do cross multiplying. X minus 240 times 1, so 1 times X minus 240 is equal to 0.40 times X. Cross products are equal when you have a proportion. Well, this one's pretty straightforward. This one is X minus 240. This one is simply 0.40 times X. Well, I have X's on both sides. Well, let's see here. I'll tell you what I'm going to do. Let's move my X's to the left. So let's first add 240 to both sides. You can do this in any order you want. This, of course, is 0, so I have an X is equal to 0.40X plus 240. And now let's move the 40 hundredths or 4/10 of an X to the left side. So I'll subtract this from both sides. That's 0. 1 whole X, I'll put a 1 here. 1X minus 40 hundredths of an X is 60 hundredths of an X. And the right side is 240. X is being multiplied by 0.60, so I'll divide by 0.60, again, both sides. This divided by this is 1. 1 times X is X. And I need my calculator for this. So 240, let's pull this aside here. I need to do a bit of math with my calculator. I need 240 divided by 0.6. And it looks like $400 was the original price. $400. Okay, so a fair amount of work in this one. Now, does it make sense? Okay, I think we can see the whole page here. Does it make sense? Well, if it starts at 400 and you subtract 40%, of 400, you're subtracting 160, and you get to 240. So it makes sense. It should be higher. And once I take 40% of 400 and subtract it, I will get 240. Now let's recap this one, because this is the one that's complicated. I knew that the original price is equal to the amount of change divided by the percent of change, but the amount of change is a subtraction problem. That subtraction problem, in this example, because the original price is higher, it's the original price minus the sale price. I knew the sale price because I'm told it's $240. I know the percent of change. It's a 40% markdown, which is 0.40 as a decimal. What I don't know is the original price. Well, it appears twice. Original price minus sale price on the right and the original price on the left. So I first substituted the variable x for those two. I realized that if I could make this a proportion by putting this over the number 1, I could use cross products. That's what I did here. I used cross products. I used algebra to move my x's together on the left, my number on the right. I simplified, solved, and I was able to come up with $400 or $400. That one's going to take some practice, is my guess. But there you have it. We have now dealt with every piece, as far as I know anyways, and certainly as far as our book, that deals with percent increase and percent decrease.